applications that you can use with dilations. Hi. So in the Scale Ella video, we were able to identify scaled copies pretty easily because the numbers were whole numbers. They were pretty easy to see, right? If the cockroach started out at 1 inch and then it blew up to 600 inches, 1 times 600, that's pretty easy to see. Most of the time, it's not as easy to tell in real life whether they're scaled copies or not. So we're going to do just a brief reminder, because I'm sure for some of us, we might need a little bit of a reminder or might not remember, have seen this part at all. To prove, so go ahead and start writing. It would help if I spell the word prove, right? To prove that these are scaled copies, we need to see if they have the same scale factor. So what do I mean by they? By they, I am talking about corresponding sides. So they, by the word they, I mean corresponding sides. So the sides that match up. We talked about corresponding angles, the angles that are like in a different location, but they like kind of match up. So what do I mean by that? So what would be the side that is on, so we got triangle A, we've got triangle B. Triangle B, that width is 6 units. We'll just say units because we don't really know exactly like if it's inches or whatever. What is the corresponding side? What's the one that matches up that's on the different shape but in the same spot as that 6? What measurement? 4, right? So in order to see whether or not they have the same scale factor, we need to figure out, well, 4 times what is going to give me 6? Then we need to look at our other set of corresponding sides, which would be the 2 shorter sides, and figure out 2 times what gives me 3. I know a lot of you guys in here have way better number sense than I ever did at your age. And there are several of you guys that are in here right now like, well, duh, Liz, 4 times blank, we'll figure out what that is in a second, gives you 6. 2 times blank gives you 3. In case you are like me and you like kind of struggle, especially if they're not nice round numbers like they were in the video, it was really easy to see the scale factor in the Scale Ella video because they were all like perfectly came up to be whole numbers. But what if you're not sure 4 times what? Or in your classwork for today, dun, 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 when you've got decimals, that makes it a little bit harder too. So the same method works even if you can't just eyeball it, like I know a lot of you guys can, but I know a lot, but if you're like me, definitely can't. So here is a foolproof way to get that, to make sure they have the same scale factor every single time. So what we need to do is find the ratio of each set of corresponding sides. So, what is a ratio? Remember what a ratio is. It's just a fraction, which is typically the way we express it. Now, in 6th grade, I know some ratios you guys had like the little 2 dots in between them. Sometimes you use the word like 2. But now that we're in 7th, pretty much once you got to 7th grade and beyond, more often than not, our ratios have a tendency to look like fractions. So I personally always take the larger one and divide it by the smaller one because it just, for me, makes it easier in my brain to calculate. But you don't have to do it that way. You could take the ratio of the smaller one to the bigger one. But I'm going to go ahead and do this. So 6 divided by 4. So that's a ratio of my first set of corresponding sides. What does 6 over 4 simplify to? What can I divide both 6 and 4 by? 2. So that means in simplified form, this is going to be 3 over 2, right? So if I did 6 divided by 4, It simplifies to 3 over 2. If you do 6 divided by 4 and you get 1.5, that's not wrong, okay? Especially those of you guys that are getting ready, that are doing the algebra standards, which I know is the vast majority of you. Despite the fact that fractions really kind of have me emotionally scarred from when I was in middle school, fractions really can be your friend a lot, especially when you need to do calculations with them. My suggestion, for what it's worth, is that you keep them as fractions because, believe it or not, they're actually easier to work with than decimals are. Okay, so then I need to look at my ratio of my other set of corresponding sides. So 3 over 2. Does 3 over 2 even simplify to anything else? Lower more than 3 over 2? Sure doesn't. Okay, so because the same ratio means they are scaled copies. If they're scaled copies, that means this also represents a dilation. Because dilations, by definition, have to create scaled copies. If you scale up one side, you have to scale up every side by the same amount. So that 3 over 2 means that those are scaled copies of each other. So what I think makes it kind of handy about using the ratio of the corresponding sides is that I've also, part 1 of your classwork is going to be determining whether or not they're scaled copies of each other. So just divide the corresponding sides, and if you get the same ratio, that means yes, they are, okay? But that also gives you the scale factor at the same time, okay? So that 3 over 2, the scale factor, if you're going from the small one to the big one, is going to be that 3 over 2. If you take each of those shorter sides and multiply them by 3 over 2, which I know a bunch of you guys were already doing, because I saw a bunch of you guys being like, 1.5. Well, that's the same thing as 3 over 2, right? So the scale factor going from small to big is 3 over 2. On the handout you're being given, though, sometimes it'll ask you for the scale factor going in the other direction from the bigger shape to the smaller shape. And the reason that fractions, in my opinion, are so handy for this is because all you have to do is find the reciprocal. Remember, reciprocal is just that fancy word for the fraction being flipped, right? Sounds a lot like the word refliprical. Sounds cheesy, but that's how I always remembered it when I was in middle school. So this, not only checking to see whether or not they have the same ratio, not only does it tell you, yes, they're scaled copies or not, but that also gives you the scale factor. So if you go from a small to the bigger copy, you need a numerator that's going to be larger. If you're going from a big copy to a small copy, you need a numerator that is smaller, because that is how you know that you are scaling down. So this should technically be kind of a summary of 7th grade content. Just wanted to make sure I gave you a reminder. So that's going to definitely be the easiest way to identify whether or not they're scaled copies or not, is to divide those corresponding sides. Is anybody not okay if I scroll up? Because I want to show you one other thing that hopefully will make a connection to math. You heard the girl say a word in the video that was proportional, right? So by definition, scaled copies are proportional, okay? Proportional simply means, do they simplify to the same ratio? You heard the word proportional a lot last year. What does proportional really mean? It just means that they have the same ratio. So for it to be a scaled copy, they have to also be proportional. And it's just another way of saying that they would have the same, like 2 equal ratios. Is it okay if I scroll up to the picture? Okay, notice this little imaginary dotted line that they've drawn here through the diagram. I'm wondering if this is going to jog anybody's memory. When you graphed proportional relationships last year, there was something special that had to happen when you graphed like two things that were proportional. First of all the data points had to make a straight line. They had to be linear. But then there was something else also. Do you remember what it is? It's got to go through the origin. Yes. So does this kind of remind you a little bit of going through the origin? If you take your two scaled copies and you line them up vertex to vertex, so you've got your two scaled copies, you line them up like this. Yes, dear? Can you wait for like 2 seconds? Okay, and you line them up exactly like this. You should be able to draw a diagonal line that goes straight through all of the corresponding parts. So if you start here at the matching vertex at the bottom, see how that line goes straight through the top right-hand vertex that goes through those corresponding parts? Okay, so this is another way you can kind of eyeball it and see whether or not something is a scaled copy or a dilation. You should be able, because they should theoretically be exactly the same shape. So you should be able to line a diagonal up, and the corresponding part should line up that way too. So those are a couple different methods that you can use to determine whether or not they are dilations.